Hey guys, so today in renewable energy engineering subject we are going to start a new chapter, that is economic analysis. So in this chapter we are going to see various type of cost calculations and various types of payment and repayment systems. So let's go one by one from the syllabus. So as you can see in the syllabus, so the points are initial and annual costs, basic definitions, then present words calculations, various calculations, then payback period and clean development mechanism. So these are the topics which we are going to discuss in economic analysis. So mainly everything related to money. So how we can calculate the money in future and present, and different formulas through which we can calculate. So we'll see that all one by one. So as we know that design, construction and implementation of all the engineering systems are ultimately decided by economic decisions. So economic decisions takes more important role in deciding various factors of designing. So as you are an engineering student, you should have also understanding about the importance of economics, and you must be able to conduct economic analysis such as life cycle cost, net present value, payback period, etc., to assess economic feasibility of any engineering system that we should use or install that engineering system or not. Now, based on this, the renewable energy systems in general require more capital investments compared to conventional energy systems. So, as a result, the economic feasibility and the life cycle cost analysis of this renewable energy systems are much more involved. So, the cost plays more important role in this unconventional source of energy because it is more costly than conventional. So, more calculations are required in this. So, the renewable energy sources such as wind, solar are playing an increasingly important role in present and future energy scenarios of both developed and developing countries. So, let me give an example. In US, United States, the installed wind energy has increased from 12 gigawatt in 2006 to 47 gigawatt in 2011, averaging a 30% increase over 5 period. Over the same period, global wind energy capacity has increased from 74 gigawatt to 238 gigawatt. So over so engineering students, as you are studying, and the future engineers who will be involved in making decisions on design and implementation of this renewable energy systems require knowledge of economic and life cycle assessment of the systems in order to make an informed decision. However, conducting an engineering economic analysis of renewable energy system involves consideration of central and state tax credit, renewable energy certificates cost related to environment, carbon credits, etc. etc. So, environmental impact and sustainability, as well as tax credit and incentives, play key roles in conducting an economic analysis of renewable systems. So, we will start with our first topic, that is initial and annual cost. So, this was the basic that why we are studying this chapter, that why this is an important need. So we'll start with initial and annual cost. So as we all know uh, that renewable energy system is not designed to meet the complete energy requirements. So if a system is designed to supply 100% of energy demand at all times, the system will become oversized for most of the time. So the resulting initial cost would make the investment uneconomical. Hence, the renewable energy system is used in conjunction with auxiliary conventional system. So, the initial cost and installation cost is sum of fixed cost and variable cost. So, the fixed cost includes the costs of sensors, control equipments, etc. The variable cost varies in proportion to the system output. In the case of solar thermal system, the variable cost includes the cost of the collector, the storage, the heat exchanger, etc., and their installation cost at the site. The variable cost is proportional to collector area, while the fixed cost is independent of the collector area. So this is an example of initial cost. Then comes the another cost, that is annual cost. So the annual cost of installed system is a sum of many factors. So this may include the cost of fuel or electricity consumed by the auxiliary energy source. Then next is repayment on the loan taken to install the system and maintenance or cost of the system. Then comes local taxes, etc. Then some benefits are also available in form of certain type of tax deductions, so that can be deducted. This severe this will serve as incentives for installing the system by helping to reduce the net annual cost. Thus the annual cost is defined by this formula which I have described here. So generally the cost of fuel, electricity, repayment of loan, tax deductions are these major items. Then next topic is few basic definitions which you should be familiar with before knowing the analysis, before doing any economic analysis. So we will go one by one with these basic definitions. So there are four basic definitions which we are going to study. So first is annual savings. So annual savings is savings on fuel or electricity minus repayment on loan after taking solar system minus maintenance charges, local taxes, etc., plus tax deductions. So the term savings on fuel or electricity is difference between the annual cost of fuel or electricity consumed by the conventional energy system and the annual cost of fuel electricity consumed by the auxiliary system. So that is the annual savings. Then cumulative savings. is the sum of annual savings over a period plus the cost of an equivalent conventional system minus the initial down payment made at the time of installation of renewable energy. So cumulative means to over period of time. That is first year, how much savings you are doing, then addition of second year, addition of third year. So that is total savings up to over a period of time. Is cumulative savings. Then, so this cumulative savings helps in finding out the payback period. That after how much year you can you get your payback. Then the next definition is life cycle savings. So it is the cumulative renewable energy savings calculated over the lifetime of the system plus the resale value of the system at the end of its life. So what is the life cycle of any system? That is 10 years, 20 years. What is the life and how much savings it will happen on that system? So that is the lifetime saving. The term net present value (NPV) is also used very often in place of cumulative savings or life cycle savings. That is net present value. Then next is last payback period. So it is the time needed for cumulative savings on a fuel or electricity or income from a power fed to the grid to become equal to the total investment on the renewable energy system. That is how much you invested, that will become equal to savings. Then your that much time is called payback period. So for example, if you're installing a solar panel at your home and maybe it cost you around 2.5 lakhs, so the the time period by which you save that much amount of money by using that solar panel, so you're not paying that much cost of the electricity, so that time is the called payback period. So suppose it takes around 5 years to get your money back. So if you are installing a solar panel, then it may be that you will pay very less to the electricity consumption. Maybe if you are getting a 2500 rupees electricity bill on an average per 2 months, then the yearly cost will be around 15,000. The yearly cost will be around 15,000. Then if the investment is 1.5 lakhs, then it will take around 10 years to get that 1.5 lakhs. So it depends on how much electricity you're consuming and how much you have installed the solar panel. So if the annual annual cost of electricity you consume is around maybe around 50,000, then the savings will be more high. So it depends. So at what period your savings is you are getting back. So that is called the payback period. Then next topic is present worth calculation. So what is present worth calculation? So present worth is the current value of a future sum of money or stream of cash flows. Means what it is saying that the present worth of a rupee needed n years from today, what will be it? So suppose the present worth of a rupee needed for n years from today will be given by 1 plus d, raised to n, where this d is called discount rate. If we assume that the payments of a1 to an for 1 to n years are happening, the present worth of this payment will be similarly a1 upon 1 plus d, a2 upon 1 plus d whole square respectively. So the sum of this present worth, if you have to find the sum of this present worth, then it will be sigma a aj and sigma running from 1 to n and 1 plus d raised to j. So this 1 plus d raised to j is called present worth factor. This 1 plus d raised to j is called present worth factor. So it is called present worth factor, this PWF. Thus S, the sum, that is sigma j running from 1 to n aj into PWF. So this is PWF, present worth factor. So we can write PWF. So frequently the payments A1, A2, etc. are related and increase at a constant rate, that is I. So A2 will be equal to, so let me erase all and write again. So the sum is sigma running from 1 to n, that is aj into PWF, that is present worth factor, and PWF is what it is, 1 plus d raised to j. So now, as we were discussing, that a2 will be equal to a1 into 1 plus I. Similarly, a3 will be equal to a1 into 1 plus I whole square, etc. and above. So the sum, what is the sum? So sum, we have written that S is equal to sigma aj upon 1 plus d raised to j 1 to n. This we have written. So as we have found the relation that for any terms of j, we can write a1 into 1 plus I raised to j minus 1. So this relation we will use here. So the sum will be equal to a1 into sigma 1 plus I raised to j minus 1 upon 1 plus d raised to j. So sigma 1 plus I raised to j minus 1 upon 1 plus d raised to j. So this is the formula of finding sum of present worth. This is the sum of present worth. So we will see examples on this, and it will be more clear in examples. And this is also asked in GTU exam, this definitions and this present worth calculations. So this is an important topic. So we will see few examples also in the next lecture. So for that we need to remember this equation. So this So thank you very much. Okay, fine.